Okay, so now that we have a Promtail service pushing data to a Loki service, and we've set up a Loki data source in Grafana and we can read it, in the Explore tab, Loki, and it shows log browser, we can continue. When you open Loki, it already has some information from the Loki data source about the kind of information that it's already collecting. Now, the information that we're seeing here has come from our Promtail configuration. If we look at the Promtail configuration from the last video, where we downloaded and installed the Promtail binary, we created this one scrape config here. We named it system. It targets the local server. It has a job called varlogs, and it has a path variable, so it's scanning everything in the varlog folder star log. That's a wildcard for anything log. So varlogs there. We can see that here. Our job is varlogs. This file name is also created, and that's because the scrape config path property here is showing us all the file names it has found that follow that pattern. Okay, now I can see both of those options there because I've got them highlighted here. So I can unhighlight it or highlight it again. Same thing with job. I can make it active or not. If I make job active and then select varlogs, it then shows me here this string here, job equals varlogs. That string is called a log stream selector. That's one of the required things we need when we're doing a LogQL query in this window here. So very quickly we can just press show logs and it's put it into there. Job equals varlogs. It's showing me everything in the job varlogs in the last 1 hour. So if I just scroll up, these are all the log lines from all the files that scrape config has collected. And we can look at each of those individually and open it up. And we can see it has two labels, file name and job. So looking at job equals varlogs, every one of these has job varlogs. The file name will be different. For example, that's varlog auth-log, whereas that is varlog syslog. Okay, so that's a log stream selector. So if we go back to log browser and deselect that, press file name, press varlog auth-log, that's also a log stream selector there. It's just a different one. If I show logs, it's showing me all the logs it has where the label file name equals varlog auth-log. So if I open those up, you'll see the label file name equals varlog auth-log. So all these lines here all have file name varlog auth-log. And that's the log stream selector. Now we can do more with the log stream selector. We can select two log streams at the same time. So go back to the log browser and I'll select auth and sys at the same time. So if we look at the log stream selector now, there are a few differences. There is a tilde there indicating it's using a regex pattern, equals regex, and that is a pipe character. So varlog auth-log or varlog syslog. So let's show logs. It's now showing me all the lines from both of those files. So that one is varlog syslog. If I go further down, varlog syslog, and there's a varlog auth-log that was still open from before. Okay, so going to my documentation, we've seen the log stream selectors. Now inside the log stream selectors are operators. Okay, and this is an example of using a regex. There are several of them here. There's equals, which is the most common one you'll see. For example, job equals varlogs there. You got a not equals. Down here, I've got file name not equals to varlog syslog. Also regex matches. So we've seen that. We've searched for a regex, varlog auth-log or varlog syslog, and regex does not match. So all these examples here, we can type those by hand into the search query. For example, if I was to delete that and create a curly brace, it's given me the available labels that it knows about in the last 1 hour. I only have 2 labels, so there's no point in me changing that to 24 hours, for example, because I still only have 2 to choose from. But if I just selected file name there, it then says equals, and then it shows me what values I can search for in file name. That's everything that our Promtail scrape config has found and put into the Loki service for us. So file name equals the DBM package manager log. So I can run that query. And then that's everything it has in the last 24 hours. We can see that something was installed, libcbin, for example. Okay, so now let's say I wanted to search for all of those. The 2 ways we have of doing that are job equals varlogs, because just so happens I have one scrape config and the job name was varlogs. Or I could say file name equals, using a regex, that's the tilde character there, dot plus, like that, end it off with a curly brace. Press shift enter, and that will return all the file names. For example, varlog syslog. If I look at that one, that's varlog syslog. Most of the time it's varlog syslog. I'm sure there's some auth ones there. But let's say I didn't want one of those, comma, I'll write file name again, not equals to syslog, for example. And then shift enter or press run query. Okay, so it's giving me all the file names, auth logs in there. We'll find the DBM package manager logs as well. But we won't find anything in there with the label file name varlog syslog. Auth log, auth log, auth log. Anyway, that is outlined here. So you can read more about the log stream selector operators. Now, looking at filter expressions. Filter expressions allow us to filter what's returned from the log stream selector even more. So let's go back to job equals varlogs. So I've got everything that I can find where the label job equals varlogs. Job varlogs. I can say I only want the jobs with the word error in them. So some of those will have error, but it's quite hard to see. So let's level equals error there. So I can say pipe equals error. So everything in here now has the word error in it. Now for this filter expression here, it doesn't work to actually write equals equals like that, or just a single equals. It needs to be a pipe equals. The pipe is quite an ambiguous character to use, but that's just how it does, because pipe is the same as writing or in a regex expression. But that's how you use that filter expression. If you want to include everything with error, then you use those two characters there. In older versions of LogQL, you could just do that, but that now shows an error. But in the more recent versions, that says give me everything with the word error in it. Okay, so we can say give me everything that doesn't have error in it. So for that we can use the not character, not equals to error. So everything returned doesn't have the word error in it somewhere. Now moving on, we could say we want to use a regex in our query. So in that case, we'd use the pipe and then the regex tilde. And we could say, give me everything with error or info. Now the pipe is used twice here, there and there. In this expression, that means give me everything that matches the regex. And in the regex, that just means the or, so error or info. So we'll see everything with error or info. So shift enter. If I scroll down, there's error, error, info, error, info. So we can find error or info in those results. Let's say I didn't want error or info. I could say not regex error or info. Okay, so everything returned doesn't have error and it doesn't have info written anywhere in there. We can do more than that. Sometimes you might get a line with error and info in it. So you can say, give me everything with error, but not if it contains info. So we're getting error there, and none of those lines also contain info, which is quite hard to find in this result set anyway, but just showing you that it can be done. Also, we can do another one, invalid user. Regex, invalid user, we'll find everything with invalid user, followed by Bob or Redis. So there may be a few of those. Press enter, there's none of those. If I check in the last 2 days, there are 2 occurrences of that. There was invalid user, followed by Bob, and invalid user, followed by Redis. I could just say, give me everything with invalid user, shift enter. And we can see all the attempts where someone's tried to log into my server and all the usernames that they're using and their IP addresses. This is pretty normal for a server on the internet. Also, if we were logging web server logs, we could also search for status equals 403 or status equals 503, and that would be a regex for that. If you know regex can become quite sophisticated and quite long. So we'll see some more regexes later. Okay, now we'll look at scalar vectors and series of scalar vectors. Okay, so the data returned so far are returned as streams of log lines. Okay, so log lines, many log lines, and we can look at them individually, how Grafana tries to break them up. But that's the line as it's written in the text file. We can't really graph that, despite the fact that Grafana in the explore section is creating a graph of that. So for example, if I just put job equals varlogs, it's drawn us a graph and it's colored it in some way, grouped it into common information like info, error, and unknown. If we look at the tooltip there. Now, if we use the log visualization in the Grafana dashboards, it won't show us a graph. It will just show us the log information there. So I'll quickly demonstrate that. So I'll copy that, go into create dashboard, add a new empty panel, select the logs option just there. Select Loki and paste your LogQL query into there and just click out of it so that it binds. That's the information that we're seeing in the log panel. There's no graph there, but if you wanted to see a graph, we can do that. And that is by converting our log lines into scalar vectors or a series of scalar vectors. Okay, so what we do is we wrap our query into a function that somehow counts our data. So the first one, count over time, shows a total count of log lines for a time range. Okay, going back into the Explore tab, I'll discard that and I'll do that query again. Curly brace, job, varlogs, count over time, bracket, and the range, 1 minute. Okay, so that has taken our log lines and created two scalar vectors. So it's done a count of varlogs where the file name label equals varlog syslog. Also another one at the bottom here where the file name label says varlog authLog. In the last 1 hour, there are only 2 log files being written. If I change that for last 24 hours, then there are 4 log files that it can create scalar vectors for. It's quite hard to see. There are some blue dots down here. That would be for the droplet agent update log. And there's a yellow one just over here, which I'll zoom into. And that is for varlog Debian package manager log, just down there. I can zoom into that even more. Zoom out. Okay, so that is taking our data, our log lines, and converting it into a graph by doing a count on the information that it's getting back from the log stream selector, just there. Now, this range parameter here, we need to put in, that's a range of how far back it should count every time it creates one of these scalars for us in graph. So for example, if I look at this value just here for varlog syslog, it says 16. In the last 1 minute, that range, there are 16 lines in varlog syslog. At that point there, in the last 1 minute, there are 21 occurrences of a log line in varlog syslogs. And that's what the 1 minute is there. I could say, give me that for 1 hour. Shift enter to update that. Okay, so now the graph is a little different. If I zoom out, we can see here that at this point here, in the last 1 hour, there are 1,321 lines in the varlog syslog file. I could even do 1 second. There's not many. Let's try 10 seconds. There we go. So the last 10 seconds at this point here in the varlog syslog, there were 11 occurrences. Go back to 1 minute. There are 21 occurrences in the last 1 minute there. So that's what the range property is about when you use these functions that convert your log streams into scalar vectors. Okay, there's another one. Rate is very similar to count over time, except it's showing us the rate per second. So once again, if I was to look at that value there is a rate of 0.667 log lines per second in the last 1 minute at that point there. So that's how you read that. We can also do a bytes over time count. Shift enter. If I zoom into that section there, that is because sometimes a log line might be very long and contain a lot of bytes. You may want to know something like that. And we can also get the rates of the bytes per second as well. Okay. When we're converting our query into a scalar vector, we could also limit it using a filter expression. For example, I'll copy that. Shift enter. Job equals varlogs that contain error, but we're counting over time with a rate of 1 hour in that time range. So I'm going to change that to last 12 hours or last 24 hours. So count over time, varlogs that contain the word error. At this point here, for the last 1 hour, there were 360 entries. Okay, now aggregate functions. Now what we've been looking at so far are series of vector scalars. So I'm getting 2 series here. So when doing the count over time, job equals varlogs for 1 hour, for example, it's giving me a new series broken up by file name there. So I'm doing job equals varlogs, but because each of my log lines has 2 labels in it, the other being file name, it's giving me 4 different series, and you can see in the different colors. Now I can do a total of all of those, which would then become a single scalar vector by wrapping that into an aggregate function such as sum. So sum is one of them. Shift enter. It's now giving me the total of all of them. It's no longer broken that up into the different series dependent on the name of the label. It's now done sum, count over time. It's now giving me 1. There are other ones as well. We can get the maximum of count over time or the minimum count over time. There are several of them there. Average, standard deviation, standard variance, a count, which is count the number of elements. So count. Okay, so here there was 2, a 3, 2, a 3. Over here there was 4 file name series that contain log lines with labeled job varlogs. And then down here we've got bottom K and top K. Now these won't convert all our series into a single scalar vector like these other ones do above here. These will give us only 2 series or 3 series of the bottom values depending on what we use for K, or the top value dependent on what we use for K. So an example, over here there are 4 series returned because I can see that when I use count. So if I zoom into that, I only want to know where the values were highest. So I can say top K 2, comma, and it's only going to show me the top 2 series now, even though there are 4 series to choose from. Okay, so it's just showing me the top 2. I want to see what the bottom 2 series were in that collection there. So bottom 2. And it's showing me the bottom 2 series. So at that point, there were only 2 series that contained log lines, being file name varlog syslog and file name authLog. but at this point, there are other file names being written. That's a Debian packager and the droplet agent update. So that's the use of top K and bottom K. I could say, give me the bottom 3. There we go. Now I've got bottom 3 or bottom 4, which is just going to give me all of them anyway. Okay, so there are some examples there that you can use. And of course, you can also filter those further down. Say, give me everything with error or everything with info, etc. Now, not only that, let's say our count over time varlogs 1 minute, for example, returned 4 different series based on the labels in the information. So there are 2 labels here, job equals varlogs and file name equals whatever the name of the file name was. We could have a 3rd label, which I'll show you in the next video, and we can choose what we're going to group by. So for example, I'm saying sum, give me the sum of everything as 1. I don't really want 1 anymore. I want to split them up again, and I'll use by file name. So it's broken up again. So that's essentially exactly the same response as what was returned by that. But I'm saying explicitly to group it by file name. Now this is good in those cases where you have more than 2 labels in each of your log lines. I only have 2, so I'm not really changing the query much. So it's quite a useless query, that one. But let's just say I had another label called host, for example. We could group by host. And not only that, we could group multiple log streams and etc. You can read my documentation for examples if you want those kinds of things. Now, comparison operators is another thing we can do with the aggregate functions there. For example, show me the count over time of job varlogs 1 minute where it's greater than 4. Press enter. Okay, so that's given me a total, being the sum, where the value was greater than 4. So none of those values are less than 4, but we could have less than 4 if we wanted to. There's nothing there. What about less than 10? Nothing there. Less than 20? There we go, there's a few less than 20. So same things, greater than or equals, not equals. There's a few examples. Logical operators, and we could say, give me something where the numbers are greater than 4 or less than or equal to 1. So I'm going to copy that, put that in there. Sum count over time of job varlogs 1 minute is greater than 4 or less than or equal to 1. So everything's over 4 anyway. So in this example, I change that to 24 hours. Oh, another example, values between 100 and 200. Copy that. Well, there's not very many values between 100 and 200. Anyway, operator order. That's the order of how operators are processed. That's common in computer programming. If you don't wrap your operations in brackets, it will default to a particular order. An example, PEMDAS is an acronym that you can use to understand that. It'll process parentheses first. If you don't have that, it will then move on to processing exponents, multiplications, divisions, additions, subtractions in that order. Anyway, some examples there. We'll see that there are no parentheses in there, so it's processing the exponent first, then the multiplication and division, and also the modulus, and then the addition. And that's the same equation, but with parentheses wrapped around everything. So there's a particular order. There we go. Okay, LogQL. You can read more about LogQL here, the official documentation. It's very versatile, and you can do anything to it. Okay, and that will become more useful when we create a dashboard later. Now, in the next video, I'm going to set up Promtail service on another server down here, showing you that you can set up multiple Promtail services, all pointing to the same Loki service that Grafana is pointing to in this Loki data source. And you can have as many of those as you want on all of your servers. Anyway, excellent.